Hi everyone, this is Sunny Kumar from IIT BHU and welcome to my channel Code with Sunny. And today I am going to discuss the problem generate the random point in a circle. Index number is 478 and the problem is of medium type of lead code. Okay, so let's discuss the problem now. Given the radius and xy positions of a center of a circle, and we have to write a function rand point which generates a uniform random point in a circle. Please note the term uniform. We have to generate the uniform random points, okay, that are in the circle. Okay, so there are some important points also given along with. Let's read it out aloud. Input and output values must be in floating point, okay, and radius and xy positions of center of the circle is passed into the class constructor, okay. A point on the circumference of the circle is considered to be in the circle. Oh yes, that's what I want to get that, okay. Rand point returns a size 2 into array containing x positions and y positions of the random point generated, okay. So we have to do that, okay. So how we are going to approach this problem and what should be the logic to this problem, let's move further. Okay, so I'm going to just write down the code and along with I'm going to explain why this is happening and what should be the exact logic to that. Okay, so let's move further. Okay, so I'm going to do one thing. Let's write it down. First, let's define the pi values. Let's say constant. Okay, constant double, and I'm going to declare my pi as 3.14159, and it would be like 26535897 then I have 73 I think, and then it should be like that. Okay, I think it doesn't matter about that. Okay, so also I'm going to declare three variables of double type, double m radius, and it would be like also m x center, that would be center. Okay, and I'm going to also declare another variable of double type, and it would be like my center. Okay, and let's move further to write down the functions. So in the constructor I need to declare uh, I need to declare the m radius, mx center and my center. So let's do that. Okay, so m radius should be written as I'm going to write radius simply, and what should we do in case of mx center and my center? I simply assign them as it is. So my mx center would be simply x center, okay, and what should be my my center? My center would be simply y center. Okay, let's move further. So I need to declare the rand point function now. Oh, so how I am going to write the my rand function? So let's focus on that. Okay, so first I need to we all know that to have a general equation of a coordinate on the circle, we need to write the coordinates as x equals r cos theta and y equals r sin theta. Okay, so for generating the random point, we need to generate a random degree and we need to generate a random radius to be so that we can generate any random point in the circle or on this circle. Okay, so first let's define a random degree theta. Okay, so I am going to write here double theta should be twice into, and I am going to write the value of pi, and into let's call a function uniform. Note that I need to generate a uniform function, that is uniform points. So let's define a function here again. I need to write a function here double uniform that needs to return the uniform random values. So let's write it down like return the double value of random values, that is random is going to generate it as like let me write here RAND, rand function, and let us divide it by rand max. Okay, I think this should be fine. Okay, so this will return the double value. So I have generated the random theta, and what about generating the random radius? Double r equals, I think you should write as rand. No, many you viewers will think it must be the double radius, that is rand. It should be rand function directly. That is, I need to call a uniform function. Sorry, I need to call a uniform function. But this doesn't happen. Why this doesn't happen? Because it does not generate the uniform function, uniform random points. So the reason is that let's move to analyze the with the help of picture. Okay, so let's move to that. Okay, so you can see here I have a diagram here. So that is going to denote the reason, specific reasons why this is happening. So let's look at the math that leads to the square root of random. Because I am going to write my new radius as r equals to square root of uniform function. So why I am taking the square root? This is because let's write it down. Assume the simplicity that we are looking with the unit circle, that is r equals to 1. So let's first assume that we are looking for the unit circle r equals to 1. So the average distance between the points, you can see these are the points. The average distance between the points should be the same regardless of how far from the center we are going to look. Okay. So this means that, for example, that looking on the perimeter of circle with circumference 2, that is, I am going to consider this now, circumference 2, we should find twice as many points as the number of points on the perimeter of a circle with circumference 1. Okay, so you can see if I am going to look on the circle with circumference 2, we need to find the number of points exactly equal to the double. Not going to say exactly, I want to say that twice as many likely as for the circumference equal to 1. So in that case, we need to consider such a method so that it can generate the uniform random points for every r. Okay, so I'm going to say one thing. I'm going to add one thing more. Since the circumference of circle 2 pi r, we all know that the circumference is going to be written as like 2 pi r. Circumference 2 pi r grows linearly with r. It follows that the number of random points should grow linearly with r. So in other words, we can say the desired probability density function grows linearly. Okay, so according to these concepts, there is another involvement that we can also say that according to the according to you can say that I want to add one more thing. uh, we are going to use a trick, inverse transform sampling. If I'm going to consider the inverse transform sampling, it says that for generating the uniform radius, we need to consider as r equals square root of the random function, sqrt of random function. Okay, so I need to consider the square root of the random function to generate the uniform points on the circle. Okay, so also you can also, there are many reasons to prove that. Also you can say, note that the point density is proportional to the inverse square of the radius. So hence instead of picking r, we can pick from 0 to r max square. Inversely you can say r is going to be the square root of the theta. Okay, so I can say so it will be as simple, just take a square root of the random function. Okay, so let's move further. Okay, so I need to complete this one. Okay, so I need to take a square root of this uniform function. Okay, then what should be our answer in this case? That is, return vector of double. I'm going to return the double, so it would be like, just simply write down mx center, because we all know that any point on the circle or inside circle can be written as r cos theta, x as r cos theta, and y as r sin theta. I have generated the random theta, and the random r is going to be generated with the help of square root of uniform function. Okay, so mx center plus radius into m radius, and it should be multiplied by cos of simply theta. Okay, and I need to give a comma here and need to write another parameter, that is my center plus r into m radius, and it should be multiplied by sine theta now because I am dealing with y coordinate. I think this should be fine. Okay, so I should give a here. Okay, so let's run this function and check it out if this is going to be a fine or not. Okay, so yes, it is fine. So let's submit this code directly. Okay, so if you have any doubts, do not forget to mention in the comment section of the video. And I will ask the viewers to like this video, share this video, and do subscribe to my YouTube channel for latest updates. Thank you for watching this video.